All right, so Polya's four-step process. Give me some initial impressions of this. And Kelsey, we are reading through this. Initial impressions of the Polya method.
We do a lot of these plans all the time without really even thinking through like, oh, like this is how I'm going to try and approach it. So it's one of those things where this is like actually like think about your approach.
Absolutely. It's just being disciplined. Like this is a very common sensey kind of thing. But being disciplined about this can pull us out of all kinds of jams. Other initial impressions of Georg Polya's four-step process.
It's like not rushing to try and answer it right away. Just make sure you know what you're doing, and that'll help you think about the problem as well.
That might be the biggest thing of all. Understanding the problem before you jump in to solutioning kind of stuff. So let's spend some time talking about step one. So pull it up. All right, do we understand all the words? What are we being asked to do? Can we restate? Are there any pictures or diagrams that could help us figure it out? And is there enough information at all? So here's how I would relate this to programming in particular. Just about any programming problem can be thought of as a great big black box that takes in inputs and turns them into outputs. This is all software. I type in the following things, I see the following thing. I click on the following thing, I see the following thing. I pass these variables into a function. The function returns these things. Because it fractals inside of this. It's almost like a conservation of matter kind of idea. We can't get information from nowhere. We can't output it to nowhere. And like the systems design world, that's called immaculate conception. That's called a black hole. And yeah, within this, same kind of thing, all the way down, from our application to our methods to everything. So in this step one, so much of what we're doing is figuring out what the arrows are. What are those? So let's get a little bit more concrete with it. Just a sec. I'm going to pull up the thing that I worked through yesterday. So people who are in my live coding session from yesterday will recognize this problem. All right, so here's the problem as it was given to me. Probably clean up some formatting there a little bit. But really, this is what we're being asked to do. So what I want you to do now is apply some Polyus step 1 stuff to this. What are the arrows? What kinds of questions could we ask? What are some Polyus step 1 things that we can do if somebody gave us this problem to solve? Let's take another 4 minutes on this one. Go. Even if you saw me do this yesterday, still worth doing the exercise. In a minute and a half. All right, back together. So I'm going to call on some people. I want to see what we can tease out of this for Polyus step 1 kind of stuff. Reed, give me one example of something that we can pull out of this.
In terms of like what the arrows are.
Sure. Any of
Yeah.
the arrows.
Sure. Okay. Well, it would be, I guess the arrows going in would be this this array of strings.
Yeah,
Or
an array
yeah.
of strings. So that one actually took me a second when I was doing this yesterday, because that's such a goofy ass way to deliver the data for this, but we don't always get to pick our problems. So they're giving us an array of strings, and the strings look like that. Cool. Alan, anything else poly step one stuff you picked up?
Sorry, it's on my notepad. Yeah, so basically what it wants us to do, right?
Mm-hmm.
So one thing that I was looking at is sorting the rides, right?
Mhm.
Like how are we supposed to sort?
Yeah.
That looks complicated because initially I just read the start of it. It says sort the rides by type.
Mm-hmm.
What kind of type, right? Then it says, by the estimated wait times. Like that sounds to me like that is a sort inside of a sort.
Yeah, it does kind of sound like that, right?
Mm-hmm. So
Um,
I'm still sort of stuck in that section of it, but so far as understanding like what it's asking of me, the big question what it's asking of me,
yeah.
I think first step is to calculate that wait time. So figure out how to draw that out and make that formula happen.
Mm-hmm. So the calculation is definitely a part of this. The sorting is definitely calculation. There's a calculation in this. There's sorting of some sort involved. Now, like, Jeff, you're going to be next. This is one hell of a sentence here. Let's see if we can tease this one apart and see what they're actually asking us to do. It's worded super fucking poorly. Like, this is not a clear-cut question. Also, spoiler alert, this is the technical challenge for Comcast for junior devs. They don't send you to like a special school to write these questions well. So, Jeff, can you give me an idea of what they're asking us to do in this last thing here?
Yeah, I mean, I kind of just listed it out by each task, but I think it's important to understand, like, isn't the final thing we want is that final, the sorted list of rides by title, ride type, and estimated wait time. So I think that would be like this final, the right-hand arrow, right?
Yeah, so like some sorted list. That's what we're trying to get out of this. Now, you'll note too that they were real specific about what we're getting in. It's an array of strings. They're not so specific about what we get out. They didn't say an array of objects or also an array of strings or so. And to this day, I still don't know what they actually wanted out of this. Anybody else have thoughts on what they're asking us to do in this sort?
It might be like, yeah, sort of just a big nested hash or something.
Yep. Like, I like that idea. Any other thoughts on the sort?
Yeah, I was gonna say, since it is starting off with a string or like array of strings, it
Mhm.
might just want it in like the same, I guess I would say format of data.
Yeah. How many different sorts are there in this last thing?
Well, there's the wait time.
Mm-hmm.
Let's see. So initially we need to. It's kind of like, okay, I don't want to take everything back to the Hashkeball, but kind of like the Hashkeball. Like there's like the right title, and then what type it is, and then the estimated wait time. But all of that also need to be organized by. It says that they need to be alphabetically organized
Mm-hmm.
by the title only.
So
Like
is this all one sort?
Wait, I'm sorry. What was the question?
Is this all one sort that they're asking us to do?
Well, there is a sorted list. So basically, the way that I would think about it is like there would be a sorted list, and then it would contain an array, and
Okay.
then it would have like ride number one. Like there's going to be a title, and then it's going to be like obviously it's going to be the one with like starting with the letter A or so,
Sure.
and then have a hash, and then estimated wait time, and then it would move on like that, I guess.
Let's spend more time with this because it's ambiguous, and I really want to make sure we're clear on how gnarly this thing is.
I would say that they're telling you to do multiple sorts.
Yeah, it kind of
Just based on the wording.
But let's
Yeah, do it like this, then do it like this.
let's try splitting this apart a little bit. Just make these different lines. So everybody take a second and look at this gnarly sentence they gave us. I've been looking at this problem for 24 hours now, and I've thought the answer to this question is two different things with like absolute certainty twice now. How many sorts are there?
I count 6.
The other, why do you think it's 6?
Well, if they don't, the word, yeah, the word sort doesn't show 6 times, but it says sort the ride by type. Okay, that's 1. Then with each ride type, sort, yeah, then that block is 1. Then for rides of the same type and wait time, that's 2, or that's 3. Then the next one is 4, then the next one 5, and then finally 6.
Okay.
But I could
How many
definitely
arrows are coming out of the black box? Do you think there's 6 arrows? Any other numbers? Here's how I parsed through this. Here's how I did it yesterday. Sort the rides by ride type, and then with each ride type. So I'm thinking that's the same sort. But you can sort something at multiple levels and go, all right, I want to support, so sort everything by type. And for everything that's the same type, the next characteristic that it should sort on is what? Alphabetical by name, how long the wait is. And so what they're saying is sort the rides by ride type. So they've got roller coaster and what do we got? Simulator and merry-go-round. And so these are all like types of rides. Within that, so like if I can add that, I think it makes more sense. Within each ride type, sort by estimated wait time from shortest to longest. So that's not a different sort. That's not a different output from the box. It's just another condition on that same sort. And then for rides of the same type and wait time, sort them in alphabetical order by title. So these two definitely belong together. And I think it kind of makes sense that sort by the ride type and then the wait time. And then if two things have the same type and the same wait time, then they should be alphabetical ascending. So yesterday, I took that as all one output that's got 3 levels of sorting on it. And then sort the list of rides with each ride's title, ride type, and estimated waiting time. I took that as a second one. So this thing should have 2 outputs from it. Earlier today, I was convinced that it was these 2. Now I'm not, or these 3. Now I'm not so sure. But this is Polya step 1 stuff. These have different implications. What do you actually ask me to do? Especially since this is the result we're going for.
Yeah, isn't the last one just an output? Isn't that like the final product?
I think both of these are alternative final products. Because
right, but like you have to go through the first sort and then do all of that work, and then it's going to output the second sort, right?
I don't think so. And the reason I don't think so is because this would undo all of the stuff that you did here. If you're sorting by title, you're not also sorting by type. You can sort by title after you've said, oh, these have the same type and the same wait time, but those are the only 3 characteristics they're doing sorts on. So you can't sort by type and then wait time and then by title and then by title and then by ride type and then by wait time. I still don't know if I have this right. That's the best guess I was able to make, is that this is going to have 2 distinct outputs. You sort them this way, you sort them this way. Cool. Any other Polya step 1 stuff that might apply?
I think I might be catching this, the last 2 sentences. We're given a whole bunch of inputs, and then what are we only given for our outputs though? Is that short any?
So we get, we get this array of strings as the input, and for this output, they don't specify the type, but like an array of hashes sounds perfectly fine to me.
That's not what I meant.
Oh, go ahead.
I meant so when we start off, how many things are entered in when we start off, right?
Do you mean the data?
So we've got the title, we've got this, we've got that, and then when we put it out, I'm not seeing any type for it.
Yeah, I'm not either. I'm assuming that if they're giving us 10 things, they probably want 10 things out.
But the last one doesn't have it. So I'm thinking maybe that last line is saying you're going to sort it by all of these type of things, and then you're going to shoot it to us without that. Maybe.
Maybe. These are all perfectly valid Polya step 1 questions. We also know that we have a calculation to do somewhere in here. So we get how long the ride is, how many people are in line, or how long the wait in line is. And what was the other one? The number of seats on the ride. Ooh, there's another element to this though, because we're getting this array of strings and then we need to do the calculation. Can anybody pick up the hidden task in there?
It's literally right there where it says calculate the wait time based on that.
Right. So here's the formula we need to follow. How do I get the line length and the seats and the duration?
You need to convert the strings into numbers.
Yeah, I need to liberate these numbers from this string. If I just have some string of stuff, I can't, like, I need to follow some process if I'm going to pull pieces of that string out to perform this operation. that needs to happen at some point, right? So I'm going to call that, there's like a transformation step in here. We gotta split this string into all of its little component pieces. We need to do a calculation, and then we need to do probably 2 kinds of sorting. So the next step that I would do as part of like a programming kind of thing, sample inputs and outputs. So I think we broadly have the idea of what they're asking us to do. We have an idea of what the kinds of inputs are. But we think we know what this output is all about. Kind of idea of like what steps might be involved. It's technically probably a step 2 thing. The last thing I would do in step 1, it's kind of like bridges step 1 and step 2, is make an input-output table. So you're telling me if I give you this array of strings, I'm going to get back this specific array of hashes or whatever. And they're going to be in this order and what have you. So you try to come up with some examples of what this black box would look like if it worked. And so I think it helps to think of it as pure magic. All right, if I have a magic wand in here and I give you these things, we'll know it worked if this comes out. So what I did last night when I did this was I wrote those out as tests. So you're telling me if I have this array of strings, it'll turn into this output. If and this is getting into like, this is where bridges step 2 a little bit. If I call this function with that and tell it to sort by title, it should equal that. And if I take those same inputs and tell it to sort by this, it should give me this output. You're doing this in a whiteboarding interview, any kind of technical challenge. This is where you and the interviewer or whoever are agreeing on like, what does winning look like? That's an awful lot of time when you go, oh, cool, line length divided by seats times duration. Cool, let me just write a quick function for that. You start diving into some kind of implementation. When I did this last night, I spent half an hour on this part of it. And I'm pretty good at this. Questions about poly is step 1.
When we were doing a while back with John, we did sort of like a mock interview thing.
Mm-hmm.
And we did, and I saw the input and output boxes. So that's, I mean, it's probably good in more broad scenarios, just to make sure that you understand how this is working, not just for like, oh, like this is probably a good thing to do when you're doing like mock interviews or something, or a real interview.
Oh yeah, this is like normal part of the process. So yeah, when you're doing whiteboarding interviews, they go, write a function that reverses a string. And so you go, all right, so I'm clarifying the what and the why. How long can the strings be? And then they go, oh, I'm so glad you asked. Infinitely long. Like, whatever, you're trying to figure out what the boundaries of the thing you're being asked are. Am I already guaranteed that I'm getting a string? No, I'm going to accidentally give me a number or something like that. So I'm going to figure those things out. And then you go, so you're telling me that if I get cat, I should return tack. You're telling me if it's cat with a capital letter, I get back capital C, not capital T. Empty string comes back with an empty string. Palindrome stays the same. That sort of stuff. So like that is go-to for whiteboard interviewing. And like production programming, when I'm writing apps, I do the exact same thing. I just do them with tests. But you have to figure out what winning looks like first. Otherwise, how will you know you got there?
It's just basically making the expectations like super, super clear. So
Yep.
no chance of just a misunderstanding being your downfall.
Correct. Let's say you get to the end of the string reversal thing and that person goes, but what about, I don't know, man, we talked about this when we did the IO table. Why didn't you tell me about that then? Other questions about poly step 1?
Would this be a good place, like since it was kind of that last paragraph especially was poorly written, to maybe just like rewrite that or break it out into bullet points or like
Oh, bless you. So you're telling me what you want me to do is take an array of strings. Each string has like pieces of data, but they're kind of locked in that string. I'm going to need to do a calculation with parts of that string, and then I'm going to need to sort the result several different ways. The process of wrestling that into words, it will set you on the path of trying to solve the problem. All right, let's talk about step 2 a bit. Who can remind me what step 2 is?
Making your plan of attack.
Making your plan of attack. So we know that we have to do these 3 things. I think logically it would make sense to do them in this order. We transform the strings, we do whatever calculation we're going to do, and then we sort them. Anybody think of any other ways that we could attack that? Think about that title sort in particular. We're going to sort by title. How else could we solve this problem? Reminder, the inputs look like this. I could do the transformation, the calculation, then the sort. What else could I do?
Do the sort first, then effectively append your calculation after you've got it done.
Love it. So these strings, if I sort these strings alphabetically, like my sort's done. I don't need to later also sort it. to Alan's point, I can also go through each one of these and just do the calculation in place. I can do it within the string. Give me whatever the thing is between the second and the third comma and do the calculation, take the result, tack it on to the end of the string. That's a valid way to solve the problem. So the point is you want to get creative with it. Even if you have like a kind of obvious solution like this, that one that I just mentioned, that's actually more efficient than this one. It'll run way faster. Especially if like it's a very long list. Doing it in place, way faster. Do the sort first. Now it's way less flexible because we have a few different ways that we want to sort. But this step 2 process, don't get too married to a solution right away. Go, all right, cool, I have that potential solution. Any other way I could do this? Any other trade-offs that I'm not thinking about? Even if you end up going with the same one, you still end up thinking about the problem more deeply. Questions about Polya step 2? Somebody please remind me what step 3 is.
Implementation.
Yeah, work the problem. So mod 1ers, this is a lot of what was happening in your Haskell review. As you're working through whatever your solution is, make the problem smaller. Smaller, 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 small as you can. So when I was doing this last night, all right, I have this input and this output. When I start working on the solution, can I just turn one of these into something that's more like this shape, even if the data isn't right? It feels like that would get me one step closer to having a working solution. If I take this string, transform it into something like that. And then this is problem decomposition. We start the whole problem over again. All right. If what you were asking me to do was just take this string and turn it into this object, all right. Do I understand what I'm asking of myself? What would some sample inputs and outputs look like? What ways could I do that? And in my case, I wanted to take that string and turn it into that object. And so I wrote a little test for it. And then my implementation was this. And then when I ran my test, I found out, oh, I need those to be numbers. So I had to do that little coercion on them. And I went, okay, well, I can do it with one of them. Can I do it with a list of them? So I did the exact same thing, but I did it in an array instead. Totally worked. All right, well, now that I have those, if you just gave me this, could I calculate the wait time for it? All right, if I have these inputs, can I call this thing and get that output? It's the same process. It just goes all the way down, just like this does. And hopefully, you go down, you come back up, you go down, you're going through all these things, and when you come out the end, hopefully you've made your transformation. So this came up in the first session today. Sometimes you do something like that and you go, oh, fuck, this is way different than I thought it was. This solution is actually not going to work. There's another thing that came up as I was working on this. It doesn't have to be linear. You can go back. You're like, oh, okay, I guess I didn't understand that part of it. So let me go back to step one. You can go, this solution sucks. Let me go back to evaluating different potentials. Given the things that I just learned from this, what else you got? That's what step 3 is all about. I think of it as, what is the smallest thing that I can do that makes this problem easier? And then you just keep doing that. Ask me some questions about step 3.
That was a good life lesson.
Hell yeah.
Like how the Palia put it, is solve a simpler problem.
Yeah, that's it. If we go to Haskell, come on, there we go. Okay, so when we're working through Haskell, one of the first things they ask us is, you need to find these like players. Oh, but the players are in these 2 completely separate things. That's a hard problem. So if you jam them all into one array, it's not so hard a problem. And I think that's a totally valid way to approach problem decomposition. You know, this problem sucks. What's the problem that I wish you had asked me? What's the data that I wish I had? All right, how feasible is it for you to get that? It turns out it's not so very bad. And then your solution for num points scored gets a lot easier. More questions about Polya step 3?
Can you go back to the code for it?
Yeah. Haskell or the solution for this one?
Oh, for this one. Okay, so in terms of, yeah, putting it into the way that you want it to look, you had it sort of stacked. But when you ask for a return value, like of, yeah, say you just want the name of the ride and all the stats, like, is it, how do you know if, like, they want you to return it in a specific shape, like if it's stacked or if it's a long line of code? Or
so when somebody's asking about this stuff, they generally don't care about how it's presented. What they very well might care about is like, all right, did you want an array of hashes? Did you also want an array of strings back? So do I need to restringify like these hashes? They didn't specify. And like, that's a big piece of missing information. So they don't give you that? Well, whatever, you make a smart guess. And that was my smart guess.
All right.
But yeah, whether or not they're all on one line or different lines, as long as it's readable, they're generally not too picky about that kind of thing. All right, let's talk about step 4. Reflect. This is the one that people miss the most, especially when they're doing whiteboarding interview. So like some examples of reflection. So you take this IO table, you take this, try running these inputs like into your whiteboarded fake function and see if it actually works the way that you think it does. Do you actually get tack back? You need to verify that you actually accomplished something. And in my experience, when you do this check step, you find a mistake you made about 50% of the time. The greater than sign was pointing the wrong way. Should have been less than. Should have been less than or equal to. I asked for index 0. It should have actually been index 1. Like dumb shit like that. Wrong variable name.
Could we use binding.pry as like a tool for like checking our work?
You totally can if you're working in Ruby. But this, somebody asks you to do something like that, like it's on a whiteboard potentially. And so you need to go, all right, so I'm going to reverse some string, and then I need to let the result equal a blank string. And then I need to turn this string into an array of characters. So I go string array is explode string. Exploding is when you take a string and make it an array. And then you take that array and maybe you iterate from the end of it. So you go, all right, for I is string array dot length -1 while I is greater than 0, decrement it. And then do result dot pushing a whatever the string array at I, something like that, and then returning the result. So like a whiteboarding interview is doing what I just did. And the step that everybody forgets is, all right, so for example, let's say that I have cat. So starting up here, the result is going to be an empty string. And then the string array should be an explosion of that. So I should end up with C, A, T. All right, and so I is string array dot length -1. So string array dot length is 3, -1 is 2. So I'm saying that that's 2. While 2 is greater than 0, all right, it is, do these things. So result this empty string. Oh, what do you know? I actually found a real fucking error. This wasn't me trying to make a point. This is me actually making this error. You can't push something into a string. You concatenate it. So I go, oh, what I actually meant to do was result plus equals string array at I. All right, so now if I do that, result is an empty string and string array at I. We said that I is 2. So the string array at 2, index 2 is T. So now this is T. All right, and so then I goes down. So that becomes 1. Is 1 greater than 0? Yeah, it is. So string array at index 1 is A. And then it goes down again. So it goes down to 0. is 0 greater than 0? It's not. So we're done. Ah, and I found another mistake. I honestly I wasn't putting on a show for y'all. I go, oh shit. It's okay if it's equal to 0 too, because otherwise I didn't get my last letter in there. So is 0 less than or greater than 0? Well, that's true. So now this is 0. String array at 0 is C. So result is C. I goes down again, so now it's -1. Is -1 equal to or greater than 0? It's not. So we're done with this loop. And we return the result, which was tack. So I passed in cat, and I got back tack. That's this reflection step. Check your work. I've been programming for a long time. I made two mistakes that I was not intending to make on this. You will too. It's not a big deal to make a mistake. It's a big deal to not catch your mistake. Other questions about Polya's 4-step process?
Any comment? I was surprised to see that this was for mathematics.
Yeah, a little bit. So my 8-year-old asked me the other day. He goes, "Hey, what are your favorite like problem-solving methods for math?" His teacher's super into like coming up with alternate strategies and stuff. What strategies do you like? And I said, I like Polya's 4-step process. It's a generic problem-solving strategy that works for all kinds of different things. And he goes, Daddy, I meant more like number line or pictures. It's like, all right, buddy, don't get to big dog me with arithmetic. But I told him I draw pictures. Other questions about Polya's 4-step process?
I guess my question is not exactly, well, I mean, in a way it is, but what are your expectations on how long should a person spend on each step? I know they're not all time consuming on the same level, but which step would you spend more time on?
1 and 3 often take the longest, but since it's a generic problem-solving strategy, kind of hard to say actually. Yeah. So to give you a sense of scale, like me actually solving this problem yesterday, I probably spent about half an hour on the first step, not long at all on the second step, but not none, 2 or 3 minutes. I spent probably 45 minutes on the third step, and then about 5 minutes on the last step. Now, the good news is that since I was writing code, I didn't have to run through the solutions by hand. I had automated tests that I'd made. So like I kind of got to check my work as I was going. But as an example of something that came out of there is like, well, all right, if I'm looking at this code and I'm thinking about what I like about it and what I don't like about it, God, this is fucky. Hang on. If I'm thinking about what I thought is good about my solution and bad about my solution, one of the things I didn't really like is I was using a bunch of if statements for like which way I should be sorting. And I hate if statements. So I was like, that gets gnarly if I have other things that I want to sort on down the road. And so I was like, I could make an improvement by doing this crazy thing that anybody's been through mod 3 knows what this is, but this is like total pro move way to get rid of an if statement. I couldn't write the solution that way originally, but I could refactor it to that on reflection. It's another good thing that comes out of those step 4s. Yeah? What's up, baby? Oh, come here. You want to say hi to my students? This is Miles. Miles just got an Advent card. Miles, what do we have on our Advent card? Eat popcorn pizza. So I'm looking at this Advent card. I don't think this is an official brand Advent card. Eat popcorn pizza, you say? All right, you can eat some popcorn pizza tonight. Here you go. I know you do.
We have a lot in common.
Real legit.
So, like, that's another kind of thing that you can do in the reflection step is go, all right, could I improve this at all? And I came up with something there. Now, since this process fractals, though, if you look at the tests, this like calculate wait time one, the entire process end to end was probably under 2 minutes. There's also ones where figuring out what you're being asked, pretty easy. Sudoku solver is a good example of that. All right, so you're saying if I have this board, I end up with this board. If I have this board, I end up with this board. Coming up with potential solutions for that, very difficult. You're gonna spend most of your time in step 2. And once you come up with a viable strategy, step 3 is probably not that hard. So those are some factors that might influence how much time you spend in one step versus another. And then since this exact same shape applies to an entire app, all right, if I put in my location and my credit card, the output is the screen telling me the driver that's coming to pick me up. Well, now you're looking days, months, weeks, years. But you can break that problem down smaller. Other questions about problem solving?
So like I can see myself getting into a situation where try to solve a simpler and simpler and simpler problem.
Mhm.
And eventually you're like, I'm solving the wrong simpler problems.
Yes.
You know what I mean?
Oh, that happens all the time.
Yeah.
And the way to not do that is practice. There's not like a bulletproof way to stop that from happening.
It's so funny you say that because while I was reading that thing that you sent us,
Mhm.
it said this requires patience and care. I
Yes.
was like, those are the two things that I do not have. I have everything else but that.
So one of the tricks that you can use, especially if you're using automated tests to help you stay focused, is all right, I have this big high level problem up here. I'm going to skip that test and work on this smaller one, and then I'm going to skip that test and work on this smaller one. Then I'm going to skip that test and work on this smaller one. And then when I get that figured out, I go, okay, well, this one should pass now. And now this one should pass now. This one still doesn't pass. So I need to start going down again. But in skipping those, you're making a note that will help you remember what the real thing you were trying to solve was. And at some point you go, all right, well, did I actually solve the problem? I did. We're done. But I'll use those. So like I wrote this test. So I wrote this test first, the very first thing I did, but that's the entire problem. And so then I went, all right, cool. If I skip that, what's the next smaller thing? And I just look at all the tests that I've skipped and unskip them. And that's how I figure out whether or not I have more problem to solve. That's a trick, but like, if I'm being honest, so much of it just happens inside your head. And it's one of the reasons that like testing takes a long time to get good at. Cool. Hopefully this was useful. Survey's coming out soon.
Thanks, Kyle.